Good morning class. As we had discussed about your congruency in triangles, today again we are now about to discuss about your exercises C. On the very first day we had discussed types of congruencies. There are 5 types of congruencies if you remember. You can go through, turn your pages, and I told you to write it down in your notebooks. There are 5 types of congruencies which you have done it in class 8 and we are recalling it in class 9. So we just have to observe the figure. Geometry we did lines and angles, and I had told you in the beginning itself, geometry is all about observation. If you can observe, if you can see this blackboard, whiteboard in front of you, and you can observe certain things about it, that is very much required for the geometry. Alright, all the questions, everything will be marked in the figures. You just have to identify and write it down. Nothing much. For example, exercise 7.1, page number 118 says a quadrilateral ACBD figure is given to you. He did not say ABCD, he says ACBD. So you can see how this quadrilateral is made. This is a quadrilateral. A, B, this is C and this is D, and it is marked. This AC is equals to AD. In the question he says AC is equals to AD, and AB, this AB bisects this angle A. Bisect means it divides this angle into equal parts. So write down whatever is given to you. What is given to us? We are given in quadrilateral ACBD. AD is equals to BC. AD is equals to AC, and AB bisects angle A. What you have to prove? You need to prove that is triangle ABC congruent to ABD? Is triangle ABC congruent to triangle ABD? Congruent, equal in all respects. How many sides, how many angles? We know there are 3 sides, 3 angles in a triangle. So out of those 3, we just need to find out, we just need to see 3 things. SSS, SAS, RHS and so on. So what does this construction? Not required, everything is constructed for us in the figure. We just have to observe. So we can see this triangle is talking about and is talking about this triangle. Which are the things we find equal? 2 things are already given to us. AD and AC both are equal. Marked also. And this angle is also equal to this angle. We can see this angle is X, this angle is also X. Why? Because AB is bisected. Bisects this angle A. Right? So, in triangle ABC and triangle ABD, just observe carefully. AC is equals to AD, given to us. Is it given? It is already given. And then angle CAB is equals to angle DAB, again because AB bisects angle A. Again it is given to us. One more thing we need to observe, which is that one thing we need to find out, which side, which angle, any other side, any other angle that is equal. We can see this side AB is a common part for both the triangles. AB is a part of triangle ABC, AB is also part of triangle ABD. So AB is equals to AB, that is common side. So we can see 2 sides of the triangle are respectively equal, and the angle between 2 sides is common included angle. So therefore triangle ABC is congruent to triangle ABD by what congruency? SAS. 2 sides, yes, and the included angle. So therefore, and if 2 sides, 2 triangles are congruent, can we say that this BD is equals to BC? Which word? We have used the word CP in lower classes. So therefore, BC is equals to BD. Reason CPCT. What does CPCT stands for? CPCT is equals to congruent parts of congruent triangles. Yes, we have used this in lower classes. Nothing new. Correct? Same questions are there in the entire exercise. We just need to observe. Not the exercise only, and in the entire chapter you can see. All the questions are same. If you talk about question number 3rd, 4th, see, I am not solving question number 3rd and 4th. I am just explaining it. See what does he say? AD and BC are equal perpendiculars. This is an equal perpendicular, he said. This is one, this is another, this is D, this is A, this is B, and this is C. Right? They are equal perpendiculars and it is marked in the figure for you. These two are equal. Right? Then he says a line segment AD and BC are equal perpendiculars to a line segment AB. Show that CD bisects AB. This is CD. We need to show that this CD is bisecting this line segment AB. Bisecting means we need to prove this part equal to this part. Can you see that? And it is marked as O. So we need to prove that OB is equals to OA. Can we see two triangles? Yes, sir. In these two triangles, we just have to identify equal things. We can see AD is equals to BC, one side equal. Angle A is equals to angle B, that is 90 degree. Right? So what is given? Let us do. Given AD and BC are equal perpendiculars. This is the sign of perpendicular. We have used it in lower class previous chapter. And what we have to prove? We need to prove that OA is equals to OB. Construction not required. Everything is constructed. Just and just observation proof. Just and just observation. In these two triangles, we have to see things. In triangle DAO and triangle CBO. Angle A is equals to angle B is equals to 90 given to us in the question. Can you see that? It is marked. Then AD is equals to BC, that is also given to us in the question. And thirdly, now we have to identify or we have to look for an angle. Can you see? When two lines intersect each other, vertically opposite angles formed are equal. It was given to you in your half-yearly assignment. Is this angle equal to this angle? Angle AOD equals to angle BOC, that is vertically opposite angles. So therefore, triangle DAO is congruent to triangle CBO by what congruency? Two angles are said. It is not RHS congruency. Why RHS not? Because hypotenuse is not equal. Opposite to right angle, this is the hypotenuse. Hypotenuse is not given equal. So one angle 90, another angle, and one side it is not the included side. So which congruency? AS. Yes, and if these two are congruent, can we say that this OA is equals to OB? So therefore, OA is equals to OB. Reason CPCP. Right? Correct? Only observation. If you talk about question number 4, it is the same. Check. Parallel lines are given to us. We have discussed about lines in the previous chapter. Lines L and M are two parallel lines intersected by another pair of lines. Another pair of parallel lines. This is one line, this is another line. Right? This is line L. This is line M. And both are intersected by another pair of parallel lines. This is one pair, one line, and this is another line. Yes, this is line P and Q. This is P and this is Q. The segments are given to you. This is A, B, C, and D. Right? And you can see a line. What is this line? These lines are individually called transversals. We have discussed about them in the previous chapter. What does he say? He says, show that triangle ABC is congruent to triangle ADC. What is given to us? We are given Line L is parallel to M, P is parallel to Q. What you have to prove? We need to prove that triangle ABC is congruent to triangle ABC. Construction not required, proof. So in triangle ABC and triangle ABC. See, the name itself gives us the solution. Triangle ABC and triangle, just look for the order. AB, BC, BC, angle A, angle B, angle D, angle C. You will find the answer in it itself. See, can you see? Is this side AC common to both the triangles? AC is equals to AC, common. Only observation, nothing else. Right? And then we can see this is a transversal. Is this angle equal to this angle? Alternate interior angle. We have used this property. Page number 100 of your textbook. Is this angle equal to this angle? Again, alternate interior angle. Angle BAC equals to angle DAC. Then BAC is equals to angle is equals to angle DCA. DCA. And angle BCA equals to angle DAC equals to angle DAC. Reason for both of them: alternate interior angles. So now you can see two questions on the board. Here it was AAS congruency and here it is ASA. Two angles and the side included in them. Triangle ABC is congruent to triangle ADC by what congruency? ASA. Right? So these are the properties. First question, SAS congruency. Second question, AAS congruency. Third question, ASA. So these are the three questions that we have discussed in the previous class. Now, question number 2nd and question number 5th, they are the same. Please practice it. In the next video, we shall be discussing these questions as well. If you have any doubt, you may send me your queries. We can do it. If you talk about question number 5, let us talk about question number 5 also. You will find there is a relation. Let us see question number 5. What are the things given to us in question number 5? He says, an line is bisecting one angle. A line is being bisected. An angle is being bisected. Sorry, not a line. My mistake. He says, line L is the bisector of angle A. This is angle A, right? This is angle A, and there is a line L that is bisecting this angle. So this is line L. It is bisecting this angle. That means this angle is equal to this angle. Let me call it as X. Right? Then he says, and B is any point on L. B is any point on L. Say this B. And from this B, perpendiculars are drawn to the arms of angle A. This is the arm of angle A. These are the two arms. So one perpendicular is dropped over here, and another perpendicular is dropped over here. Right? That is BQ and BP. What is given to us? Line L bisects angle A, and BP is perpendicular and BQ is also perpendicular on arms of angle A. What we have to prove? We have to prove triangle APB congruent to triangle AQB, and second, BP is equals to BQ. BP is equals to BQ. No construction, everything is considered. You can see triangles. Just observe, nothing else. In triangle APB and triangle find, can you see this angle X equal? Because it was given to us that it is bisecting, line and is bisecting. Write it down. No harm, write it down. So we can say that angle PAB is equals to angle QAB because L bisects angle A. Right? Then angle P is equals to angle Q, that is 90, given to us in the question. And one more side, which is that side? Can you see this side AB common? And AB is equals to AB, that is common. Now triangle APB is congruent to triangle AQB by what congruency? Now here you said, sir, hypotenuse is equal. One angle is also 90. 90 opposite to 90 is the hypotenuse. Hypotenuse is equal. It is the common side for both the triangles. So can it be RHS? Sir, right angle. H for hypotenuse, R for right, H for hypotenuse, but S stands for side. Is any of the side equal? No. One angle is equal. So again, which congruency? A and S. A and S, not RHS. And first, if these two triangles are congruent, is this BP equals to BQ? Yes, sir. BP is equals to BQ. Reason CP. Is this side AP equals to AQ? Yes, sir. CP. Correct? So these are very easy questions that you have to do, we have discussed. Question number 2 is also easy, you can find it out. Then in the next video, because 2nd and 6th we shall be discussing together, so we'll be doing it together. Thank you.